The most successful battery players won't be the ones who build fast. They'll be the ones who build with intent. My name is Tolu Aribisala, and I'll be your host. And I'm joined by Mark Bellino on the fifth installment of our Build Better Batteries series. We'll be discussing what it means to build a battery project with intent, how to garner trust in an industry that's filled with bold claims, and what separates a resilient project from one that struggles to deliver on its promise. Welcome, Mark. Great to have you on.
Thank you.
So, just building upon the last four conversations that we've had, are there any key takeaways that you'd like to share before we go on?
Absolutely. Just maybe refreshing our memories. The four videos focused on four areas that we've analyzed in various projects within the battery space, also applicable outside of the battery industry, um, that are common modes of failure. And the first being technical risk management. You got to iron out those really big risks that will cause the project to fail. And that requires test work, thought process, and a rigor at the end of the day to understand and appreciate that there is risk and to mitigate those risks. The second is planning. You have to plan what you do to have the foresight in terms of what you need to do today to be ready for the tasks that will come in 2, 3 months down the road. Otherwise, you'll get caught. And that'll cause disruptions to schedule and often lead to really big cost penalties on the project. The third is you have that plan, now execute it diligently and do the detailed engineering that you need to do to have an asset that has been comprehensively designed and therefore can be constructed appropriately so that you have something that when you push the start button, it technically works. But what we found is you also need a fourth piece, and that is to be ready for operation. We could design a plant perfectly, but if you're not ready for operation in the sense that you don't have operating systems available, ready to go to facilitate maintenance, and you don't have trained operators who understand when things are deviating to catch those things before it leads to a shutdown, then you may not have a facility that will actually produce revenues. So, in the end, you actually need to focus on all four of these elements together in order to have a successful project.
So, when you look at battery projects that succeed and those that struggle, what's the clearest separator between them?
Well, when I look at projects that don't meet the mark, often what I see is that the project is run on hope. It's good to have aspirations and hope and ambitions, but they have to be backed by a plan on how we're going to achieve those objectives. And when I use the word hope in this context, it is often without a plan. It's often without the method and the rigor that's needed to achieve those objectives. People are literally just hoping that it comes together. And you can't scream loud enough and you can't force people hard enough to achieve a hopeful outcome, especially these projects, which rely on tens of thousands of assumptions, millions of things coming together. It's far too complex to rely on hope. If I contrast now the successful projects, what I see as a key differentiator is people that approach that complexity with respect. They acknowledge it, and as a result of acknowledging it, they respect it, and that prompts them to rigorously deal with the complexity of the project. With a comprehensive team, a set of players that have expertise across the entire design, including those niche things that'll often catch you on projects, and having that respect for the complexity, I see a lot of successful outcomes coming out of that type of recipe.
So, based on your experience, what's the biggest revelation that you've come to when dealing with projects like this?
When I started as an engineer, I often, looked at projects as the step that I have in front of us and executing that and then moving to the next step. So really it was from the start to the finish. What I found over the years is a far more successful strategy. In fact, I'd almost be adamant that this is how it has to be done, is flipping that around. You need to have the end goal in mind and then reverse engineer the plan. We need to have a vision of what the asset's going to look like and how it must perform, and then determine, working backwards, what you have to achieve to get to that point. And that in itself keeps people focused on a an objective of a plant that actually will be profitable and doing the things necessary to achieve that target. If you go the other way around, you almost get lost in the details. You might complete this step well, but you lose sight of the ultimate objective. You have to have that final objective in mind, and you have to design with the intent of getting there.
So, when clients are choosing a delivery partner for a battery plant, what should they actually be looking for, and how do we prove capability beyond claims?
I'm going to circle back to your first question in that what is good to draw from the four previous series that we've published. There's four clear buckets, areas where projects often struggle. One point I want to make is neither of these buckets is more important than any of the others. And sometimes I find that clients really get excited about one of these buckets and pay a lot of attention to it. For instance, maybe technical risk management, but then don't pay as much attention to another area. And then you'll have a problem that ramifies. Each of them are equally important. The second point I want to make is that they're actually very much interconnected. As I pointed out, you can design a plant perfectly, but if you're not set up for operations and can do that well, you're not going to succeed, or you'll struggle to succeed. Um, but one important aspect is in terms of the interconnectivity. Let me give an example. If we understand that operations is important, why would we not want to get that feedback from operators during the design phase? If there's something that we can flash up there beside a piece of equipment that warns the operator and assists that operator in intervening, that would be good intel to have while you're designing the facility, right? So we find ourselves using people that are focused on operational readiness to inform the design. And so now, like, what does a client want in a partner? Um, you really want to see a partner that has a capability in each of these four buckets. In R&D and can help with scale up and technical risk development, is really good at planning and executing to keep schedule and capital costs intact, is able to comprehensively design things, isn't weak in a certain area, and has a team of advisors who can set up the operation for success. I'm happy to say that Hatch with Intent, and it's because our clients have asked us for this, have assembled a comprehensive team, a team of experts in each of these areas that knows how to work together so that we can properly integrate designs and help clients build successful operations.
So, just to conclude, if there's one mindset shift that the battery industry needs to make, what would it be?
That going faster doesn't mean you finish sooner. And in fact, oftentimes you don't finish sooner. Um, Let me provide a little bit of context there. It's okay to try and continuously improve. We have systems and procedures and methods that have been optimized over the last 7 to 8 decades. And we try and employ the best of that thought process today. But as we've found in the past, we can continuously improve. And so I anticipate that things will become even more efficient in the future. But to have a cavalier approach when it comes to the execution of these projects, when you're basing your strategies on hope, I don't see that as a winning proposition. So when we talk about a mind shift change, hope is not a strategy. Planning and proper execution is a strategy. And perhaps you can look at a task and try and make that particular step more efficient, but you can't just erase the task altogether. The other thing I'd like to note is when you start these plants up, that is where all of your assumptions, all of your hard work, every move you've made will culminate into either an asset that performs or does not perform. You can no longer hide behind your hope. You can no longer hide behind your assumptions. You can only stand behind the product that you have in front of you and the planning you've done to train operators and get the facility ready for operation. And the plant will tell you whether you've done a good job. And so what we found is when you look at the economics of these projects, because of that, the ramp up curve is the single most important aspect of profitability. If you've designed and planned something well, you will likely hit the schedule in terms of ramp up, the time it takes to reach 100% capacity, and preserve the business case. Oftentimes, when we see that risk hasn't been properly dealt with, managed, and corners are cut, that ramp up curve is a lot longer than people expect. And essentially, the business case bleeds. The net present value quickly erodes, and you can find yourself in a situation with an asset that's unprofitable, which is a consequence we try and avoid. Hatch is starting to publish information on ramp up curves, and one of my colleagues is talking about the McNulty series and how these should be interpreted and what to do to try and improve your chances of hitting a good ramp up curve. So look forward to more content about that in the future. I'll be presenting a little bit on that at conferences this year, and we're excited to help clients understand that and work together to try and preserve business cases.
Thank you so much for sharing those insights. As Mark shared, the projects that endure are the ones that are designed for reality, planned with rigor, and delivered by teams that are not afraid to challenge assumptions. Thank you for watching, and for more insights, visit hatch.com.